All right, with question 9, we have to find where the curve does cross the x-axis before we can go too far. So remember, that's the x-intercepts will make y equals 0. So we've got 0 equals x squared, take 9x plus 20. So we've got to factorise this. You could chuck it straight in the quadratic formula, but two things that multiply to give 20 that add to give negative 9. So that's x take 5, x take 4. So x equals 5 and x equals 4. So we need the tangents at those points. We need y dx first. That's going to be 2x take 9. At x equals 5. We want the equation of the tangent. Yep. Y equals 5 squared take 9 times 5 plus 20. 0. Oh, of course, y equals 0. At x equals 4, y equals 0, because it's the x-intercepts. That was one of the dumber moves I've done. Okay, I'm going to pretend I didn't do that. Just shh. Dy dx is 2 times 5 take 9, which is going to be 1. So y minus y1 equals, well, I should actually state. So the gradient of the tangent equals 1, y minus y1 equals m outside of x minus x1. So we've got x take 5. Here, dy dx equals 2 times 4 take 9, which is negative 1. So the gradient of the tangent equals negative 1. Y minus 0 equals negative 1 outside of x minus 4. So y equals negative x plus 4. That's it. Question 9 was nice and easy. Okay, question 10. Let me just grab it. Okay. Let's see if I can fit it in the same bit. Find the equation of the normal to the curve x squared plus 4x at the point where x equals minus 3. Find points A and B where the normal cuts the x-axis and y-axis. And then, okay. So this time I've got the graph. Looks like this. If, you know. And at x equals minus 3, we would have a tangent to this curve there. But I'm more interested in the normal, and we're trying to find the distance between this point and this point. So that distance there. So let's find the equation of the normal first. Well, we have to find the equation of the tangent to find the equation of the normal. Dy dx is 2x plus 4 at x equals 3. Dy dx equals 2 times 3 plus 4, which is 10. The gradient of the tangent is 10, so the gradient of the normal is negative 1 on 10. Let's find the equation. Y minus y1. Well, I don't know why. At x equals minus 3. Oh, I don't think I subbed minus 3 into this. Minus 2 times 3 plus 4 is going to give us negative 2. That's a better number to work with. Means we have a gradient of the normal, which is a half. But we still need to know the x-coordinate where it does cut it, where the normal, like when x equals 3. We need the y-coordinate. Y is negative 3 squared plus 4 times negative 3. So the y-coordinate is 9 take 12 negative 3. Useful. So y take y1 equals m outside of x take x1. So we've got y plus 3 equals half x plus 3 on 2. So y equals half x. 3 on 2 take 3 is negative 3 on 2. That's the equation. We now need to find where that equation cuts the x-axis and the y-axis. So that means our intercepts. So the y-intercept let x equals 0, y equals -3 on 2. X-intercept y equals 0. 0 equals half x take 3 on 2. So x is going to equal 3. Yep. So distance between 2 points. Remember, d equals the square root. It's an application of Pythagoras. X2 take x1 squared plus y2 take y1 squared. So this is the point 0, -3 on 2. This is the point 3, 0. So we've got our distance equals the square root of x2 I'm going to have as 3. 3 minus 0 squared plus 0 minus -3 on 2 squared. I'm going to chuck that straight in my calculator. So we've got the square root of 45 on 4. So the distance is, I'm going to simplify that. Square root of 45, that's square root of 9 times 5, which is 3 root 5 over 2. That's it.